Hello and welcome to an algebra video tutorial learning about systems of linear inequalities. In this case, we're going to look at a linear system of inequalities that has no solution. So what does that mean to have no solution? Well, we know that a linear inequality, a system of linear inequalities, the solution set is if I graph both of them, the solution set is where both graphs overlap. It represents all the possible points that if I put those x and y values in, make both inequalities true. So if there is a system of linear inequalities with no solution, that means when I graph them, there has to be no place where the graphs overlap. So we're going to play around with this particular system right here. Y is greater than 3x plus 1, and 6x minus 2y is greater than 4. We're going to look at the graph. We're going to put them both into y-intercept form, and we're going to look at some things that happen when we're dealing with the linear inequalities with no solution. Okay, first thing let's do is put them both into slope-intercept form. This first one is already there. Y is greater than 3x plus 1. So I'm going to rewrite that over here. Y is greater than 3x plus 1. The slope is 3 and the y-intercept is 1. So I'm going to go ahead and graph this one here. So plus 1 is the y-intercept. That's a point that has to be on the graph. And the slope of 3 means I go over 1 up 3. Over 1 up 3. That slope just represents my change in x and y. Over 1 up 3. There's a general idea of what the boundary line is going on. I can even go backwards, left 1, down 3. And in this case, I'm going to make the boundary line, since it's just greater than but not equal to, I'm going to make a dashed line. Because all the points on the line are not solutions. So I put a dashed line to say, yep, none of those, there's the boundary line, but the line itself is not a solution to the inequality. And finally, it's y is greater than all these, so I'm going to shade up. I'm going to shade this side of the line represents all the possible solutions. So there we go. I now know all the solutions to the first inequality. Well, let's look at the other inequality now. The 6x minus 2y is greater than 4. Let's rearrange this one into slope-intercept form and then look at the graph and see what's happening here. So to put it into slope-intercept form, I've got to solve it for y, rearrange it around, get y by itself, so I can tell what the slope and the y-intercept are. So I'm going to subtract, use all the stuff that I did with algebra solving equations. I'm going to subtract 6x from both sides and move that to the other side there. 6x minus 6x goes to 0. So now I've got negative 2y is greater than negative 6x plus 4. Now to get y by itself, I've got to get rid of this negative 2 multiplying it. So I'm going to divide both sides by negative 2. Everything on both sides gets divided by negative 2. Negative 2 divided by negative 2 turns into 1y. Negative 6 divided by negative 2 turns into 3x. And 4 divided by negative 2 turns into minus 2. But since I divided both sides by a negative number, I have to reverse the inequality. So I'm going to make it now y is less than 3x minus 2. We're already probably drawing some conclusions here. Look at, we had a slope of 3 in this graph right here. We'll look at my other inequality. It also ended up having a slope of 3 once we got it into slope-intercept form. My y-intercept on this first one was 1, so the y-intercept there was equal to 1, and on the y-intercept here is equal to negative 2. So the slopes are the same. That's what's going to give me some interesting things here. So let's graph this now. So y is less than 3x minus 2, so I need the boundary line. So negative 2 is my y-intercept, so I'm going to mark that down here. My slope is also 3, so I'm going over 1 up 3. Over 1 up 3. Over 1 up 3. And what do we remember about lines that are parallel? Means they have the same slope. So this one is a less than, so again it's another dashed line, so I can't make it solid because it's not equal to, so I'm going to make little dashes representing my boundary line for the inequality. And it's all the y values less than that, so less than means I go down. So the solution set to this inequality, the red one, the second one, are all these points over here. All right, well now you can see a problem, right? We have same slopes, so these are parallel boundary lines. Parallel boundary lines never intersect, parallel lines never intersect. So if they're parallel, they're never going to intersect, and the blue line, the first inequality, is always the solutions are above the line, whereas the second inequality, the solutions are always below the line. And you can see there's this little gap indicating that they never intersect each other, and they never will because they're always parallel off forever that way and they're parallel off forever that way. So this is a case of a linear system of inequalities that there is no solution. There is no overlap at all with my solution sets graphically. So hopefully that helps get you an idea of what we're looking for. If we have parallel lines in my two inequalities in a linear system, be really careful. It could mean that they never overlap. Graph them out and see what's going on there. All right, hopefully this is a helpful video for you to understand linear inequalities with no solution.